Today I'm going to show you the demo of how distance vector algorithm works in computer network. So when I mention computer networks, so definitely it is consist of the routers. So I'm going to explain how the distance vector algorithm works. So as you can see here, the problem is in a network consists of 7 routers A, B, C, D, E, F and G. The distance vectors listed below are received by node E. Node E has measured its link cost to its neighbors A, D, G to be 5, 8 and 6 respectively. Determine the least cost distance vector from node E's perspective to all other nodes in this network as well as the adjacent node in the distance vector. So basically what does this problem is, what they are asking is, like in the network there are 7 routers from A to G and they are asking us to determine the least cost vector from node E to all other nodes, meaning E to A, E to B, E to C, E to D, E to F and G. So in this way, at the last what we will able to figure out, like they have given us the node A, node D, node G router table. So we will come up with node E router table and we will see like how this algorithm works. So first we will calculate the distance. Basically first we will see like what they have given. So they have given us the router E and their respective distances with its neighbor, like neighbor A, I mean the router A, then router D and then router G. So what are their distances? 5, 8, 6 respectively. So this is what we have. And now what we gonna calculate, like distance from E to A. So we will have to keep in mind when we calculate the distance from E to other nodes, we gonna traverse through all these nodes like A, D and G, because they have given us node A, node D and node G router table. So first we will see the distance from E to A. So there are 3 ways to traverse this, like E to A, then if we go to E to D to A, E to G to A, right? So here you can see what is the E to A distance, it's 5. Then what is E to D, it's 8. Then D to A. So for this distance we have to see in the node D router table. So in the node D, what is the node value of A? Like 5. So what is the distance from D to A? It is 5. Then we will come here, like E to G. So what is E to G? It's 6. Then G to A. So we have to see in the node G table, and what is the weight of node A? 6. So for node for distance between E to A, so what will we use? Like minimum of like 5, then 8 plus 5, then 6 plus 6. So what's the minimum distance? This will be like 13, this will be 12 and this will be 5. So what is the minimum? 5. So here E to A is 5. Right? So in the same way we will calculate the distance for other nodes like E to B. So if I consider E to B, so I need to traverse through all other 3 nodes, right, which I have mentioned earlier. So what will be E to B? Like E to A to B, E to D to B, E to D to E to G to B. So we are gonna traversing through all these 3 nodes. So what is E to A? So E to A is 5. Then what is A to B? So for this we have to see in node A table, right? So what is A to B? So we have to see the value of B. So it is 12. Then what is E to D? It's 8. Then what is D to B? We have to see in node D table, and the value of B is like 7. Then E to G is 6. What is the value of G to B? Distance from G to B, we have to see in the node G table, and value of B is 8. So here like minimum of 5 plus 12, then 8 plus 7 and then 6 plus 8, right? So 5 plus 12, 17, 8 plus 7, 15, and 6 plus 8, 14, right? So what is the minimum distance? Like 14. So E to B is 14. 14, then here it's 5. In the same way, we're going to calculate for E to C. So for E to C, how are we going to traverse? E to A to C, E to D to C, E to G to C. So in the same way, what is the distance from E to A? It's 5. Then A to C, we have to again say in the node A table, and the weight for the C is 10. Then what is E to D is 8. D to C is 7. E to G is 6. G to C is 5. So minimum of 5 plus 10, 8 plus D to C was 7. Sorry, D to C was 7. So 8 plus 7 and 6 plus 5. So minimum of like here like 15 and 12, right? So distance from E to C is 12, right? So in the same way, we're gonna calculate for E to D. So in the same way, like E to A to D, E to D, and E to G to D. So what was the distance from E to A? 5, right? E to A 5, then E to D is 8, and E to G is 6. So E to D is 8, E to G is 6, then A to D is 4, and E to D is like, we have that distance from E to D is 8, and G to D is 8, right? So minimum of 5 plus 4, 8, and 8, 6 plus 8, right? So 5 plus 4, 9, 8, and 14. So E to D is 8. So minimum distance is 8. Then E to E. E to A is 0, right? So then E to F, in the same way, E to A to F, E to D to F, and E to G to F, right? So what is the distance from E to A? 5. Then A to F, we have to see in the node A table, and what is the distance from E to F? 9. A to F, 9. Then E to D is 8. Then D to F. Then what is the distance from D to F? It's 8, right? And then G to F. What is the distance from G to F? 4. So first E to G is 6 and 4. Then minimum of 5 plus 9, 8 plus 8, and 6 plus 4, right? So 14, 16, 10, right? So E to F is 10, right? So we are calculating the minimum of all the values. So lastly, E to G, right? So in the same way, E to A to G, E to D to G, E to G, right? So E to A is 5, then A to G is 5, then D to G is 6, and in the G like 0, right? So A to G is 5, D to G is 6, right? So minimum of 5 plus 5, this is E to D is 8, and E to G is 6. 8 plus 6 and 6. So 5 plus 5, 10, 8 plus 6, 14, and 6. So this is E to G is 6. So minimum distance is 6. So in this way, we're gonna form the same node E table, like node and weight and adjacent node, right? So node A, B, C, D. E is like E to E is 0, so I'm just skipping that. So what is the node weight? 5, 14, 12. Like 5, 14, 12. Then what is the weight of D is 8. Then F 10 and G is 6. And so how we gonna calculate this adjacent node is like through which node the distance is minimum. So for E we traverse through for E to G, so it's the G. So for A is the A. Then for B, what is the minimum distance? Like 14. So this is through G. So 12. This is through again G. So adjacent is G. So here A, here G, here G. Then for D, what is the? So it is through D only, right? Then 10. This is again through G. So adjacent is G, and this is again G. So this is our like node E routing table. So this is how the distance vector algorithm works. So I just tried to explain you in a simple way like how distance vector algorithm works. So that's it.